derive expression for convex spherical surface formula when ray of light goes from denser to rarer medium. This is convex object, left hand side. This is O. This is a C. This is normal, away from normal. This is I, R. It is N2, it is N1. This is pole, this point is N. Let I is denser to rarer, ray goes. I is image, rather point image of point object. O in convex spherical surface of small aperture. As aperture small, PM is nearly a straight line and perpendicular to principal axis, and one absolute refractive index of air, rarer medium, and two absolute refractive index of glass, denser medium. This is air. Same thing, N2 by N1 is sin R by sin I. Here, denser to rarer. So N2 by N1 will be sin R by sin I. वो अप्लाई करेंगे तो वही बेस पर एंगल लीजिए थीटा अल्फा फाई tan theta ये परपेंडिकुलर है, नियरली परपेंडिकुलर एंड प्रिंसिपल PM by PO, PM by PO tan alpha, PM by PC tan phi, PM by PI और थीटा PM by PO alpha PM by PC phi PM by PI. Why these angles are small, as aperture is small and point is nearly here, so imagine about theta alpha phi as angles very small. In triangle I is MOC. MOC alpha is external angle alpha theta plus I or I alpha minus theta. Alpha is this Pm common 1 by Pc minus theta 1 by Po. R, this is normal, this triangle, this is normal, so this triangle, MCI, R is external angle, R is alpha plus phi, alpha Pm common 1 by Pc plus phi 1 by Pi, we know, and always N2 by N1, here it is sin R by sin I. Why? Because ray goes from denser to rarer medium, R by I, or N2 into I, N1 into R. Why? Angle of incidence be small, so angle of refraction small. N2 I. This is I. Pm 1 by Pc minus Po N1 into R. R is this Pm 1 by Pc plus Pi, Pm with Pm, N2 Pc minus N2 Po, N1 Pc, N1 Pi, N2 minus N1 by Pc, take this to this side, N1 Pi plus N2 Po. Number first. Now PO object to pole U, PI image to pole V, PC center of curvature to pole R. Only this is on right side, these are on left. Putting values in first, N2 minus N1 by Pc minus R, N1 by B plus N2 by minus U. It is N1 minus N2 by R. Solve it. It is N1 by V minus N2 by U. This is convex surface formula when ray goes from denser to rare. For rare to denser, N2 minus N1. Here it was N2. So replace N1 by N2 from that formula. क्या था वहाँ N2 minus N1, N2, N1. So replace for remembering the formula. concave surface formula. When ray goes from denser to rarer medium. This is concave spherical surface. This is ball. This is object. This is C. Incident ray. Any line joining C. This will be normal. Away from normal. Away. This is I. Away. This will be R. This point is M. So draw rays. Let I is image. Of object O in concave spherical surface of small aperture as aperture is small. And point nearly here. So PM is straight line and perpendicular to principal axis. This is N2, this is N1. N1 refractive index of air, rarer, medium. N2 rather absolute refractive index of glass, denser, medium. Same, rare to denser N2 by N1 sin R by sin I. For I and R, take base angle theta, alpha, phi. Tan theta, PM by PO. Tan alpha, PM by PC. Tan phi, it is PM by PI. Or theta, tan theta will be theta when these angles are small. PM by PO, alpha, PM by PC, phi, PM by PI as angles very small. I is in triangle MOC. 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 In triangle MOC, I external angle I is theta plus alpha. PM common theta 1 by PO alpha 1 by PC in triangle R. This is R. MCI. External angle is alpha. It is R plus phi. R comes out to be alpha minus phi. Alpha PM common 1 by PC minus phi 1 by Pi. We know N2 by N1 sin R by sin I, or N2 by N1 R by I. Why denser to rare? Why I R small angles. N2 into I, N1 into R, N2 into I is this, PM 1 by PO, 1 by PC, N1 R is this one, PM 1 by PC, Pi, PM goes with PM, N2 by PO, N2 by PC, N1 by PC, N1 by Pi, or it is N2 minus N1 by PC. Take this to this side, minus N1 by Pi, minus N2 by PO. This is number first. But PO, object, Pi, image, distance of image, PC, distance of center of curvature. Only U is negative. Putting in first these values, N2 minus N1 by R minus N1 by B minus N2 by U multiply minus on both sides, N1 minus N2 by R minus N1 by V. ये minus minus plus multiply minus on both sides, it is N2 by U. So this is spherical surface formula, whether convex or concave, denser to rare. n1 minus n2. Replace 1 by 2 from rare to denser medium. This is a question, glass sphere, this is glass sphere, mu is this. And ray drawn as shown. This is incident ray, this is reflected ray as shown. And PQ, PO is equal to PQ. Find distance of object from pole. Here PO is equal to PQ. It is given, let PO minus X, PQ plus X. And what is PC? It is R. We know N2 minus N1 by R. Rare to denser, N2 minus N1, N2 by V, N1 by U, N2, this is N2. N2 is 1.5, N1 is air, so 1. 1.5 minus 1 by R. N2, 1.5 V. V is this, plus X. Minus N1, 1 minus X, so it becomes plus 0.5 R is 2.5x, or it is 1 by R, 5 by x, or x comes out to be 5R. Find distance of object. And what is this? This is distance. So we have calculated distance of object. Write down the formula. Put values. You will get with proper sign conventions. Magnification in spherical surfaces. M. We have read in mirrors minus V by U. So minus V by U, minus V by U. Object distance in the rarer medium, image distance in denser medium. So it comes out to be V N1 U N2. This is M, magnification. M stands for magnification. U, distance of object. V, distance of image. N1, absolute refractive index of air, and to absolute refractive index of medium. M was minus V by U. Here distance traveled will be this. So this is magnification of spherical surfaces. Another numerical light from point source in air falls on convex surface mu 1.5 or 20 centimeter. Calculate position of image. One light source is 1 meter away. From glass surface. Here u minus 1 meter always left and 2 it is 1.5 mu is this and 1 air 1 or it is 20 centimeter. Either change this into centimeter or change this into meter. So minus 100 centimeter. We have to calculate position of image. We have to calculate. We know n2 minus n1 by r, n2 light from ground source in air. So that means air to denser falls on n2 by v, N1 by U, N2 R, it is 20, N2 will be N1 by U minus 100, so plus 100, 0.5, 20, 1.5 V 1 by 100, it is 5 by 200, minus, take this to this side, remove point, 1 by 100, 1.5 by V, or 1.5 by V, LCM 200, it is 5 minus 2, it is 3 by 200, so V cross multiply, by 3, or V comes out to be 100 centimeter. So this is all about spherical surface.